Hello and welcome back to Dr. Logic Awkwardly Does Logic. In this video, I want to get us to start thinking a little bit more systematically about what we are trying to do. Because, okay, we saw the basic modal logic K, and then we looked at a very simple, straightforward modal principle that necessity implies truth. And then we developed the logic from that, and then we considered something else, and we developed the logic from that. And we could continue on like this, or we could try to do this in a more systematic sort of fashion. Let's do it systematically. The first thing to think about is there are many different types of modal principles that we might want to be interested in investigating, some which we've already seen and some which we will get to once we've talked about kind of ways in which we can motivate these principles. So I want to kind of draw back, look very big picture at things about what are the sorts of things that we can write down in our modal language. Now, the most interesting sort of thing is going to be the things that involve the modal operators. And in particular, there are a lot of interesting things that we can say by repeating operators, one right after another. Now, you can have more complex formulas where like this bit has a possibility and this bit has a necessity, but a lot of the really interesting kind of modal interaction comes when you put the operators in a row. So we're going to introduce notions that allow us to talk about these sorts of things in a very general fashion, to talk about not just necessity and possibility, but kind of more complex modalities as a general sort of concept. So I'm going to give you some more definitions. Let me get my whiteboard up. Where's my whiteboard? Where has me? There we go. Zoom. Why must you move things around and change things on me? So the first notion that I want to give to you is the idea of putting modalities, different modal operators all in a row. Now, you're already familiar with the modalities box and diamond for necessity and possibility, but I'm going to give you a very brief argument that we should also consider negation. Because if you think about what is a modality, it is some modifier that we put to a sentence that affects the nature of its truth and falsity. So we can take a sentence and we can say, this sentence is possibly true, or this sentence is necessarily true. And we can form it in the way of adding an operator to a sentence. It is necessary that, and then another sentence. But true and false work the same sort of way. It is true that, it is necessary that, it is false that. And we already are happy with combining possibility and necessity and truth and falsity. So we can say it's possibly true that, possibly false that, necessarily false that, and things like that. So this is just, it's a very hand-wavy and linguistic-y sort of argument why we should treat negation in the same way as a modal operator, but it also simplifies things. So if you don't buy the hand-wavy linguistic argument, take the pragmatic argument. All three of these operators we are going to call modalities in the context of what we're about to define. In fact, we're going to have a more expansive definition of modality to allow not only any one of these, but any number of repetitions or alternations or strings of these modalities. So, definition, modality. A modality is any unbroken string of 0 or more monadic operators. So necessity, possibility, and negation. Now, the important thing here is that we have to admit the zero case, because we don't have an operator that signifies truth. Truth is just truth is like the foundation of everything that we are doing. So we want to be able to say that something like P has a modality, its mode is true, but we don't have any symbol that identifies this. Now, occasionally, when we need to talk about the zero length modality, i.e. the one that has no operators. Sometimes we need to be able to refer to this. So we will use just a dash when we need to be able to refer to this non-existent string. So don't get confused about this. We're not introducing new notation. This is just something that allows us to talk about, you can think of it as a name for the zero length modality. But the ones out of these modalities that are the most interesting are the ones where it's not where you have zero or you have one, but it's when you have more than one. And these we are going to call iterated modalities. So that is going to be an iterated modality is any modality that has at least two. So what we can say is of at least length 2. We will now, having this vocabulary will allow us to talk about modalities at a very high level of generality. However, there are sometimes times where it would be useful to kind of input some structure onto these modalities. And so I'm just going to give you the notion of a modality, iterated or not, that is in standard form. So a modality with at most one negation, so you've only got one of these guys, is said to be in standard form so you might have a modality that has many more occurrences of negation. However, if you can kind of convert it to something equivalent so that you end up with at most one, so either you've got none or you've got one, then that modality is said to be in standard form. Now, because of the double negation rule from propositional logic, this means that every modality can be reduced to a modality in standard form, something that it is equivalent to. So we can give you this as a lemma. This says that in any system which validates modal interchange, so the swapping of box with not, possibly not, and diamond with not, box not, along with double negation. So in any system which validates modal interchange, every modality is equivalent to a modality in standard form. And the proof of this is just basically keep applying double negation and modal interchange until you have at most one negation left. I'll just give you an example of this and you'll see how simple and straightforward it is. So come on. That's right, I have to switch mice in order to get my new whiteboard page. So let us consider the string necessarily, not, possibly, possibly, necessarily, possibly, not, possibly, necessarily, not P. This will be equivalent to, well, first, let's do some modal interchange. I'm going to take this negation and I'm going to move it over to this side of the modal operator and I'm going to change the diamond to a box. So we've got box, box, not diamond, box, diamond, not diamond, box, not P. And I can do this again. So I can move the negation over to here and change the modality. So we've got 3 boxes and then a negation and a box and a diamond and all the other bits and pieces. And now I'm going to start putting some steps together. I'm going to move this to here and then to here and change the operators correspondingly, but now I have 2 negations in a row. So I'm just going to erase them. And then look, I have 1 negation left. This is equivalent to this, and this is in standard form. So write out some iterated modalities, do some reductions to standard form, just so that you've got kind of used to these things, you know what they look like, and then start thinking about what it is they are saying. So you've got this long string of modalities, possibly with negation, possibly without. In fact, I just realized there's one more definition I want to give you. So let us go back to the whiteboard and back to the previous one. So definition, a modality in standard form with 0 negations is going to be called affirmative, and a modality in standard form with 1 negation is going to be negative. So useful things that we will use next time. But as I was saying, start just writing some of these down, do the conversions, identify, is this affirmative, is this positive? And we will have a chance to then think more broadly about what do these principles say, which ones are reasonable ones to add to our modal logics, which ones can we already derive, and all of these interesting things. So moving out and looking at the big picture. So join me next time and we will do more with modalities. Until then, take care. Cheers.